morning. Today, you're going to be learning about systems of equations and inequalities. That's right. We're the mathematicians. Yes, we are. That's what we do. Yep. So first, you start with two equations. So in this case, I'm going to be starting out with two equations that are already in slope-intercept form. So y is greater than 2x minus 2, and y is greater than or equal to negative 2x minus 6. So the first thing that you're going to have to do is get different values for both of these equations. So go to do this, so then you can plot them on the graph, is to make tables. This is how I like to do it. So for whenever you have 0 for x in the first equation, y will equals x in this equation, y will equal 0, or for when x equals 1. In the second, when x equals 0, y will equal negative 6. And when x equals 1, y will equal negative 8. So now that we have our points, I'm going to put these up in this far corner so I can make the graph and still know what points to plot. So, you're going to make your graph. I already know it's going to go down low, so I'm trying to make more space for that part. So the first plot is 0, negative 2. And 1, 0. So there's your first line. And then your second is going to be 0, negative 6. And 1, negative 8. So there's your second line. From here, you're going to want to figure out what points will be true when plugged into the inequalities. So to do this, because neither of the lines cross through the origin, which is 0, 0, we're going to be using 0, 0 as our test point. By this, when you have 0, 0 as our test point. By this, when you have each equation and you plug in 0, 0, you test if it's true or not. And I'll explain this more thoroughly as I show it. So, when you have your first equation, which was originally y is greater than 2x minus 2, you're going to plug in 0 for the y and x. So 0 would be, for the y, is greater than 2x, which we plugged in by 0, minus 2. And you're seeing if this is a true statement. In this case, it is, because 0 is greater than negative 2. So that's correct. And the way you show this on the graph is by shading whatever is right of that equation. So left in this case, left because left in this case, left because this is the origin here. So you're going that way. So you shade in all of that because you know any point that you plot here will be equal to that inequality. And you do the same with the next one. So the second equation was y, which is now plugged in by 0, is greater than or equal to negative 2x plugged in by 0 minus 6. This is also true because 0 is greater than or equal to negative 6. So that is correct. In this, you're shading all that's right of this line. So, you shade across because you know anything you plot there is going to be equal. So now, you're trying to see what the intersection between these plugged in by 0 minus 6. This is also true because 0 is greater than or equal to negative 6. So that is correct. In this, you're shading all that's right of this line. So, you shade across because you know anything you plot there is going to be equal. So now, you're trying to see what the intersection between these inequalities are. What is gonna, any point you plot will be equal to each of these inequalities. You know this, but you can find this because there is always going to be a crisscross pattern that will show you what the intersection is. So this section of the inequality is going to be Today I'm going to be teaching you about one of the two methods to solve a system of equation, and this one is elimination, and I personally prefer it. I think it's easier and just a lot quicker to me. I don't know. So these are the 4 steps, and I'm just going to be going through them in one problem. And yeah, okay. So the equation I'm using today is 8x plus 2y equals 30, and 7x plus 2y equals 24. Alright, so the first step is to convert any equation to standard form, and obviously you don't need to do that. Standard form is x plus y equals the number. And that doesn't always need to be done, but you have to have, it has to be in standard form for elimination to work. So yeah, luckily they normally give you equations already being in standard form. So the second step is to make one of the variables cancel out by finding a common multiple, or number, or whatever you want to call it. And so 8x and 7x do have a common multiple, it's 56, but it just makes things a lot more complicated. Just try to look for the easiest number to multiply by, because it just makes things really complicated and you could get mixed up in negatives and all that. So I'm just going to be doing 2y, and you don't even have to multiply by 2, you can just multiply it by -1. So in the first equation, I'm multiplying everything by -1, which gives me -8x minus 2y equals -30, and 7x plus 2y equals 24. And that's the third step. And then the fourth step is to add equations to find the first variable. So -8x and just 7x is -1x, or just -x. And then -2y and positive 2y cancel out. That's kind of the whole point of the second step. And then it equals -6. So, and you just use normal solving skills. And so you divide everything by 1, and then you get x equals 6, positive 6. Okay, and then the last one is with that variable, substitute it into one of the equations and solve. So I'm just going to use the first one. It doesn't matter which one you use. So what you want to do is you want to write down the equation, but in place of that variable, you put the number that you found. So since it's 8x, I put 8 times 6 in parentheses, plus 2y equals 30, and that equals 48 plus 2y equals 30. And then you subtract 48 from both sides, and you get, and these two cancel out, and then you get 2y equals -18. Then you divide by 2y, which leaves you y equals -9. And that's the second coordinate. And you can always check your work by going in the other equation and plugging in both variables. So 7 times 6 plus 2 times -9 equals 24. So 7 times 6 is 42, and then minus 18 equals 24. So 42 minus 18 is 24, so 24 equals 24.
And there you go, you have your answer. So it's just, that's always an easy way to check it. Yeah. Okay, yeah. And that's the end of equations. And that's the end of elimination.
And go!
Okay, so the first part of systems of equations is substitution, which is one method to do it. So if you have the equations negative 2x minus 3y equals negative 7.
Right, bigger.
So that's your first equation. And then you also have y equals 6x minus 11. So your first step, what you have to do is convert the one that's not in slope-intercept form to slope-intercept form, obviously. So one way to do this is, actually, with substitution, you don't always have to do that method because you can just plug in the y into the equation itself. You have to convert to slope-intercept form for elimination. So you can do negative, and then you plug in this for y. If you have one that's already in slope-intercept form, you can just plug in for that variable. So you put it in parentheses, 6x minus 11 equals negative 7. That's right. So then you're going to just, from now on, now that you've plugged in for that variable, you just work it out as normal. So negative 2x minus 3, now it would be 3 times 6x, which would be 18x. And then negative 3 times negative 11 is positive 33. And all that would equal negative 7. After that, you work out order of operations as normal again. So minus 33.
So the last part of the systems of equations is graphing, and you have to do this in order to, get the question right and all that. So there's 3 types of solutions with systems of equations, and solution is basically where the lines intersect. So there's none, like no solution, and that means they don't intersect. So this could be like parallel lines or just lines like that, just that never will intersect. And then infinite solution is the complete opposite of that. And that's where the lines cross at multiple points. So this could be like 2 lines, but they have the same slope and the same y-intercept most likely. They basically have the same equation, and so this would be like 2 lines, but they're just going at a constant rate at the same time. And then the last one is just one solution, and that's just like this, and they just intersect once. So yeah, I'll edit this part out. Okay, so if you have 2 equations, to graph it, you need to make a table first. So I just write x and y, and the first equation is y equals negative 3x plus 2, and you have to write down the y-intercept to start your table. And the y-intercept is when x is at 0, and in the first equation it's 2, and then 1, and then when it's at 1, it goes down by 3, and so it's negative 1 and negative 4. And so that's the table for that one. And then the next table is y equals 2x minus 3. So the y-intercept is negative 3. And when it's at 1, it's at negative 1, and then 0. So once you have your tables, you have to graph them, and I already kind of graphed them. But you can kind of tell also from the table, since these two have the same coordinates, but if you still have to graph them, then all you have to do is graph 2 points. So 0, negative 3, I go down 3, and then 1, negative 1, so over 1, down 1. And then for this one, I just do 0 and then up 2. Oh, whoops, I didn't draw the line. Sorry. Okay. And then 1, negative